Welcome. In this video, we're going to compute the surface area of a volume of revolution, namely, given f of x equals the square root of x over the interval 1, 4, we're going to find the surface of this solid generated when we rotate f of x about the x-axis. Okay, as you can see, I've sketched the square root of x, that is f of x, from the origin out past 4, but we're really only interested in that portion there between 1 and 4. So now let's sketch what our surface would look like, paying special attention to what the surface looks like between x equals 1 and x equals 4. Okay, so as you can see, I sketched the solid of revolution, and then between 1 and 4, we have what almost looks like a bowl with no top and bottom. And we want to know what the surface area of that bowl is. So recall that surface area is equal to the integral on our interval of the circumference of this circle here, given with a radius of our function f of x, times the arc length given here, which is 1 plus f prime of x quantity squared. And all of this is with respect to x. So let's quickly begin by finding f prime of x and squaring that value. So f of x is equal to x to the 1/2 power. So f prime of x is equal to 1 over 2 x to the 1/2 power. That leaves us with f prime of x quantity squared is equal to 1 over 4x. And it is this 1 over 4x that we need inside of our integral here. So our surface area is equal to 2 pi times the integral from, 1 to 4 of the square root of x times the square root of 1 plus 1 over 4x dx. And at this point, we're going to employ some ninja algebra. And what I mean is, if we have the square root of a times the square root of b, and a and b are both positive values, positive real numbers, that is, I can rewrite this as the square root of a times b. And I'm going to take advantage of that to write this x inside of this square root. So this is equal to 2 pi times the integral from 1 to 4 of the square root of x times 1 plus 1 over 4x. This can be rewritten further as 2 pi times the integral from 1 to 4 of the square root of x plus 1 over 4 dx. Now integrating, this becomes 2 pi times 2 over 3 times x plus 1 over 4 to the 3/2 power, evaluated from 1 to 4. And if you're thinking, whoa, what just happened here? Just remember that the integral we have here is basically the integral of x to the 1/2 power dx, which is x to the 1/2 plus 2 over 2 divided by, and now 1/2 plus 2 over 2, that's 3 over 2. And this is how I got that 2/3 out in front, x to the 3/2 power. And I'm ignoring the plus c constant on purpose because I'm just trying to emphasize why I have a 3/2 power, why I have a 2/3 multiplied to the front. Hopefully that little aside was helpful. Evaluating, we have 4 pi over 3 times, now we're first evaluating at 4. 4 can be rewritten as 16 over 4. And I'm writing it as a fraction because we're going to have this value plus 1/4. And that's going to give me a 17 over 4 right here. And of course, we need to write this to the 3/2 power. Now from this, we're going to subtract. And now we're going to evaluate our lower bound. So this is 1 plus 1/4. So 4 over 4 plus 1 over 4, which is 5 over 4 to the 3/2 power. And both of these are multiplied by 4 pi over 3, so I need to ensure I have these outer brackets. Now, a little bit of algebra that I'm not showing here. This will work out to be pi times 17 root 17 minus 5 root 5 all over 6. And this is units squared. A calculator approximation gives us about 30.85. And again, units, which we don't know what they are, so I'm just writing units squared.